Hello, today I am teaching current electricity chapter. The current electricity chapter is very important related with theory and practicals. The weightage of this chapter is 5 to 6 marks. So very important topic from this chapter is meter bridge experiment. Now it's a 3 marks question. Meter bridge, what is meter bridge, what is the principle, what is the construction of meter bridge experiment, and how the working of meter bridge experiment, how this experiment it is based on which method, like all this thing I'll explain you in this topic. So the question they will ask you in exam as explain, as I already shared you the screen, as explain with neat circuit diagram how will you determine the unknown resistance by using a meter bridge. So aim of this experiment of meter bridge is used to calculate the unknown resistance. So here you have to derive the formula also to calculate the unknown resistance. First let us understand what is meter bridge. So meter bridge is a device which is based on V-Stone network. This is the circuit diagram of the meter bridge. You all can see on the screen. There are 3 metallic strips. These are the L-shaped metallic strip. Both are L-shaped metallic strip, and this is the middle metallic strip, the third copper strip. These are made up of copper, okay, and from this metallic strips the current will pass. So this meter bridge consists of thin uniform wire. From this terminal A to C there is a wire, 1 meter wire. That's why it is called a meter bridge, because 1 meter wire is connected from terminal A to C. There are 3 metallic strips, copper strips C1, C2 and C3, which is fixed on the board, and such that it is they are fixing like they will form 2 gaps. The X, which is unknown resistance, which is connected in the left gap, and RB is the resistance box which is connected in the right gap. A cell E, key K and the rheostat, these are connected in series. The cell E, key and rheostat, these are connected in series, okay, and one terminal of unknown resistance is connected to first terminal of the left gap, and the second terminal of unknown resistance which is connected in the right gap. Same way the resistance box will be connected in the right gap. One terminal will be connected to this middle metal strip, and the second terminal will be connected to this third metallic strip, okay. So how will you connect the circuit? This is very important first. So this is E means power supply, battery eliminator. With the help of this we can provide the current. K is the plug key which acts as a switch, okay, and RH, this is RH. R means rheostat. It acts as a variable resistor. So positive terminal of battery is connected to terminal A. The negative terminal of battery which is connected to one terminal of key, and second terminal of key which is connected to fixed terminal of the rheostat. See, rheostat will have 3 terminals. It's a 3 terminal device. Two are the fixed terminal and one is the variable terminal. So this is the fixed terminal which is connected with key, and the variable terminal which is connected to terminal C. And these 2 gaps, there are 2 gaps, LG left gap and RG right gap. In the left gap the unknown resistance will be connected, and in the right gap the resistance box will be connected. Now the middle terminal which is B, which is the middle metallic strip which is left, it should be connected to galvanometer. One terminal of the galvanometer, and the another terminal of the galvanometer which is connected to jockey. So this is the main circuit. This way you can connect the circuit by connecting wires. After connecting the circuit, you have to note down the readings. Now how will you note down the reading? How it is? First you have to first you have to see how how this this bridge is balanced. How will you balance the bridge? So it is based on, this experiment is based on Wheatstone network, and the Wheatstone condition is the bridge is balanced when the ratios of resistance will be equal. Okay, so and it is based on null deflection method. What do you mean by the null deflection method? Wherever when you are after connecting the circuit, when you switch on the supply, okay, and if we remove the amount of resistance from this resistance box, okay, and when you touch the jockey on this wire, you will get different values of current flows in the galvanometer. But while you are taking the reading, you have to see the zero deflection in the galvanometer, and that point is known as D. D means null point. From this null point to term point A, that this distance is known as Lx. Lx is the balancing length corresponds to unknown resistance, and Lr is the balancing length corresponds to resistance box. Okay, so this is based on, very important, this is based on null deflection method. So how will you note down the reading? These are the unknown resistances. They will give you the values x1 x2 ka, okay, and suppose they have given two resistances. One is 10 ohms. Suppose they have given two resistances. One is 10 ohms and other is 20 ohms. So the equivalent resistance, when these two resistance will be connected in the, suppose x1 is equals to 10 ohms and x2 equals to 20 ohms. Okay, so the equivalent resistance xs will be the addition of these two resistances, okay, x1 plus x2. These two resistance will be connected in series. Okay, x1 का value has 10 ohms, x2 का value has 20 ohms, so the equivalent resistance will be 30 ohms. Okay, this is the theoretical value of the unknown resistance. This is the theoretical value of the unknown resistance. So same way, by experimentally you should get this value when you are connecting these two resistances in series. So this is the major aim of this experiment, to calculate the unknown resistance in series combination. Same way you have to connect these two resistances in parallel combination. When you connect these two resistances in parallel combination, what will be the equivalent resistance? Same value. If you are taking the same value, so what will be the equivalent resistance in parallel? Same way, x1 का value is 10 ohms, x2 का value is 20 ohms. Okay, so xp will be x1 into x2 divided by x1 plus x2. Correct? 1 upon xp is 1 upon x1 plus 1 upon x2. Okay, after doing the multiplication you will get this. Now x1 into x2, 20 into 10, that is 200, divided by 20 plus 10, that is 30. So if you calculate this value, you will get 6.2 approximately the equivalent resistance in parallel combination will be 6.2 ohms. So by experimentally, this is a theoretical value when these two resistances are connected in parallel combination. So by experimentally you should get this value. Okay, so this way you can calculate the unknown resistance by using the meter bridge. Okay, now back to the screen. Okay, so I explain you how to experimentally how will you calculate the resistance. Now how will you note down the reading? By using the null deflection method. What you have to do, from this resistance box, okay, on this resistance box there are so many keys where the values of resistance box are written on it, where the values of resistance are written on it. So as I explained you, if you connect this resistance x1 x2 in the left gap in series combination, the equivalent resistance will be 30. So how will you note down the reading? So take out 30 or 25 ohms ka resistance from this resistance box and tap the chalk cue on the wire. See where you are getting the zero deflection in the galvanometer. Okay, wherever you will get the zero deflection in the galvanometer, just stop the chalk cue over there and measure the length Lx from the null point to point A. The distance, the length will be Lx, the balancing length. Lx is known as balancing length, and the total length of this wire is 1 meter, that is 100 centimeter. So if you get null point as around 45 centimeter, okay, if you get the null point at 45 centimeter, so Lx ka value will be what? 45. Lx ka value is 45 centimeter and the total length is 100. So you will get Lr ka value as 55 centimeter. Understood? So this way you can calculate Lx and Lr. If you get the values of Lx and Lr, R ka values we knew already. We are taking the values 25 ohms, 30 ohms, depends on the equivalent resistance. So first we have to calculate, theoretically you have to calculate the equivalent resistance. After that you have to take a range of resistance which depends on theoretical value of resistance combination, if it is in parallel or if it is in series, whatever. Depending on that you will get the unknown resistance. Depending on that you will get you will take the resistance from the resistance box, and this way you can measure the balancing length Lx and Lr. Okay, now so this is the mechanism of the meter bridge. This way you can connect the circuit. After connecting the circuit you will note down the readings, okay, and measure the balancing length. After getting the balancing length you can substitute the values in the formula. So what is the formula of the meter bridge to calculate the unknown resistance? Is this is the formula. X is equals to R Lx divided by 100 minus Lx. Okay, R ka value when you Lx you will get from the null point and 100 minus Lx will be Lr. Okay, so this is the formula. After getting the values of Lx, R and Lr, substitute all the values, you substitute all the three values, you will get unknown resistance. Okay, so this way you can measure the length. But in theory part, if it's a 3 marks question, they will ask you what is the principle, construction, working, and after that you have to derive this formula. In theory you have to derive the formula. In practical Directly you can use the formula, okay, but in theory you have to derive it. So how will you derive? See, there is a small derivation, simple derivation is given here. You all can see the screen. See this. See, as I already explained you, so Metabridge experiment is based on Wheatstone network. Now, what is the condition of Wheatstone network? The ratios of resistance will be equal. So, the resistance will be connected here R, X and R, and the resistance of Lx and resistance of Lr. So, X upon R is equal to the resistance of Lx and resistance of Lr. Now, according to Ohm's law, the formula of resistivity is the simple formula R is equals to rho L See, according to Ohm's law, R is equals to rho L upon A. Correct? Rho is the resistivity, L is the balancing, L is the length of the wire, and A is the area of cross section. Now, the wire which are using of uniform area of cross section, okay, so area will be same. Resistivity of the wire is also constant, area is also constant. Which quantity changes? Length. Okay, so according to Wheatstone network, this is the balancing condition. X upon R is equals to resistance of length AD upon the resistance of length DC. Okay, balancing length, the resistance of Lx and resistance of Lr. So X upon R is equals to, in place of L, suppose if you are talking about resistance of X with respect to unknown resistance, the resistance of the length with respect to unknown resistance, so this will be the formula rho Lx by L, because rho and area is constant, Lx length will be changed. Same way, then we will substitute here rho Lx upon A. Now resistance divided by resistance of wire DC, okay, which is related with the balancing length Lr. So rho again same constant. This length will become Lr divided by area of cross section is also constant. Okay, rho gets cancelled, area gets cancelled. Now what is left? X upon R is equals to Lx upon Lr. X upon R is equals to Lx upon Lr. So this way you can derive the relation to calculate the unknown resistance. X is equals to R Lx by Lr. Simple derivation. So if you get this question in 3 marks, so you have to draw the circuit diagram, explain the principle, that is Wheatstone's principle, then explain the construction, and after that you have to derive this formula.